Hi everyone. Today I'm going to speak about how we have been shipping Ethereum Pectra to mainnet, especially. So what we are going to talk about is Ethereum architecture first, because we are all building on Ethereum. Then we will see the scope of Ethereum Pectra, which was a big upgrade. We are going next with the testnets. Why do they exist? We will see that on the security view. We will go through the security competition that occurred for securing Pectra, and then we will conclude. So, he said all that, we don't really care. So, Ethereum is like divided into two software layers, the execution layer that you all know about, you are a user of it, and the consensus layer. So, as I said, execution layer is users and apps. This is where smart contracts are. And there is the consensus layer, where all validators are interacting with each other. So an interesting point is that there is communications between the execution layer and the consensus layer. When you want to create a validator, you will just have to interact with the deposit contract. This is where the well-known 32 ETH is deposited. It will emit an event that will be consumed by the consensus layer to create a validator. So what is Ethereum Pectra about? It is a set of EIPs that redefine parts of the Ethereum protocol. EIPs are Ethereum improvement proposals, and some of them were on the execution layer. You have been hearing about 7702, which transform your EOAs into some sort of smart contract, but there are more. And there are ones that are really interesting that are just between the execution layer and the consensus layer, and a lot of bugs have been found in there. So Ethereum is divided into multiple consensus clients and multiple execution clients. So to make the upgrade, you have to implement all the EIPs into all the consensus clients. And so doing that, you can be pretty sure that there will be bugs, because it's a huge task to do. So first one, we have been upgrading the Oleski testnet, and there was an incident instantly. So what was wrong? There was a deposit event, just as I explained before, which the deposit contract is address 0x4232. The thing is that Guess, Nethermine, and Bezu were not listening to the correct deposit contract because it was not set. So it was just defaulting to listening to address 0. So when a deposit occurred in 0x4242, res, which was correctly configured, was saying, hey, there is one deposit. But Guess, Nethermine, and Bezu were just saying there is no deposit in this one. So when you have that, this means that at the consensus level, you will just handle a deposit on one side, but not handle it on the other side. So you will have a chain split where validators are not having the same state. So it was fixed pretty quickly. The issue was not that big. It's just a JSON file that was wrong. So nothing to be scared about. But what is interesting on this one is that the issue happening at the execution layer happens to have led to a lot of impacts on the consensus clients. So memory consumption that was not expected, and things like that. So we have seen a lot of fixes coming on Lighthouse, Prism, Lodestar, even if the issue was not coming from these specific code bases. And then we went through the Sepolia upgrade, an incident, once again. This one was interesting. Like, it was just creating empty blocks. So the blocks, the chain was continuing processing, but empty blocks. And this is really specific to Sepolia. Like the mainnet, so we have to keep in mind that we are all building for mainnet. we don't really care about testnet, right? We are looking at mainnet, building for it. So if something is not the same on testnet, then it may go wrong, because it would go good on mainnet, but not on testnet. So for the EIP 6110, which redefines how deposit events are listened to, we were expecting only one type of event coming from the deposit contract. The thing is that the Sepolia contract is different and is emitting a transfer event. So when the EIP 6110 has been implemented, it was not expecting this event. And so it has led to an error when processing this type of event that is not expected. So when an error was triggered in the parsing of the event, then the block created was just empty. How was it fixed? It was just that on each log that we are listening, we just check that it is a deposit event and not a transfer one. If it's a transfer one, we just ignore it. So testnet are here to spot issues, that's for sure. Like, if you are scared, I mean, we have seen a lot of FUD about that. Like, Oleski event, the Sepolia event, then mainnet is dead. No. I'm the security guy. If you are scared, I'm not. This is just bad luck. And in the same time, there was a security competition happening on Cantina, offering up to 2 million USDC. The results, 3 high, 3 medium, and 17 low severity issues were found. The first bug is on Lighthouse, which represents approximately 40% of the validators. It was found by Alex Filipov. And so the specs says that at the end of an epoch, which is a collection of blocks, you have to process the pending deposits, process the pending consolidations, and then update the balance of the validators, which gives the graph call we can see on the right. But the thing that Lighthouse implemented was that in the process pending consolidation, it was doing a call to the process effective balance. So it was updating the balance. And this may not have been an issue, but it was. Like, according to Alex Filipov, updating the effective balance twice will not always produce the same result as updating it once because of hysteresis. So hysteresis is just like you have to cross a given threshold to update the balance. So if you add twice 0.5 ETH, it will not be the same as adding once 1 ETH. And this was the issue. So it was handled correctly, but due to this specific hysteresis thing, it was broken, and then you can have a discrepancy in the balance, which leads to computing a different state, which leads to breaking, having a chain split, which breaks finalization at the end. Then there was a bug in Prism that I found. This one was on process pending deposits. So basically, when creating a validator, if it's the first time you do a deposit for this validator, you will have to provide a signature. And this signature must be valid to create the validator. Then if it's the second, third, or anything deposit for this validator, we don't care about the signature. But Prism was doing an aggregation of signature, because you can do that. Instead of checking each signature in a block, you can just aggregate all signature and verify them at once. The thing is that if you produce 2 deposits in the same block for a validator that was not known, the second deposit, you should not check the signature of it. But Prism was checking it due to this optimization. So basically, it gives this thing, like first deposit, valid signature, it's a success. Second deposit, no signature, it should be a success for all nodes. But Prism was failing because the signature was invalid. So same thing again. You compute a different state because of the balance. The deposit is just ignored. And then chain split, breaking the finalization. So what we can get back from those issues is that every time you just do not follow the spec. For optimization purpose, maybe for other things, but you are not following the spec. So this is the big issue. And how to avoid issues? Just follow the spec. And an open question, I don't have the answer to that, is optimization an enemy of security? But yeah, we can follow the spec. This bug found by Andy Coe was about elliptic curves. The spec says that if any input for the pairing contract is the infinity point, then the pairing result will be 1. What was implemented is that if a point with infinity was found, then we will set verified to true, because that's what the spec says, right? But the thing is that when we look at the incident response report, it means 2 things. It was not clear enough. Like, the pair may be ignored, but the multi-pairing should be computed, because you can provide a lot of points. And basically, Nethermind was implementing the second. If one of all the points is the infinity point, then I'm just saying it's OK, it's a success. The others were computing the rest of the points and ignoring the one with the infinity point, which is really different. So the Nethermind was fixed, obviously, but the specs also. This specific note that was not clear enough was just removed from the specifications. So we should follow the spec, but not always. As a summary, there was 2 incidents that happened on Pectra upgrade. These were testnets. This is here for it. Then the security audits and competitions found a lot of security issues, but nothing critical. No funds were at risk. The biggest risk, the biggest impact found was chain split that break finalization. It's bad, but not that much. So what we should get back from it is that writing specification is mandatory, no matter what, especially for Ethereum when you have multiple clients implementing it. You should follow the spec, especially, as I said, with multiple implementation. You should also clarify your spec when it is not crystal clear. I mean by that the Nethermind team should have asked the question. And do not forget that bugs are here by default. Thank you.
Do we have any questions from the audience?
Question about the contest. When you were checking the code, were you checking all clients or only one implementation?
So I did not have that much time, and to get a high severity issue or a medium was like splitting 5% of the chain, and I was splitting more than 33% of the chain. And so when you look at the clients, Prism was more than around 30% of the chain at this time. So you know that if you find a bug in this one that makes it split, it's at least a medium, or a high if it's more than 33%. So I focused especially on the big code bases that are used, like the ones that have the most share in validators, and then taking the specifications and seeing anything that is wrong.
Did that answer your question?
Yeah.
We have one more question over here.
Hey, so about Holesky meltdown, I remember, I think Lighthouse had 7 beta releases to try to fix it. So my question is, do you know whether there were some processes changes that in the future, if something like that happens, that will be that recovery will be more smoother?
About which one especially?
I mean, I'm just giving an example. Lighthouse like had 7 releases.
Okay.
About other clients, I don't know, but
Yeah.
that's the one I followed. So do you know whether are there any lessons learned? And is there any process now to make the recovery process any smoother? For example, people are always talking about like a social consensus, but as a, for example, operator, you didn't have any endpoint, for example, to choose your chain, for example, and stuff like that. So.
Yeah, so this is difficult. You can always test. There is you can deploy a local testnet to use it, but when it's in production, social consensus is the right thing at the end because we are all humans. And if for example, for the Oleski incident, the chain finalized, if I remember correctly. So it finalized, but with the incorrect state. Because it was Guess, Nethermind, and Bezu, they had more than 67% of the chain. So it finalized, but with the incorrect state. And so reverting that means that all validators should agree to get back.
But I'm saying, like, you don't, as a user, you don't have any tools to force social consensus other than just downloading what's the latest client and like hoping that it will work.
Yeah, for sure. Yeah, it's always the team that has the control, sort of. Yeah.
Yeah, I would have liked it that if it were like we learned something about it and then I don't know how, but that some tooling is developed so like users can choose their path forward.
Okay. Yeah, I did not heard about that. So sorry.
I hope that did answer the question. Okay, wow, I love security community. Like, I really do. Like, you guys are engaging. I love it. I love it. Raul, I hope you'll be a gentleman.
Thank you for the talk. Generally curious, I'm not familiar with consensus clients at all, like working primarily with Solidity. How easy for you is to spot the bug in this code base? Like, I prefer always play with things. Yeah, like spin it up locally, writing tests, trying and breaking things. So what is your procedure generally? Is it, if it's not secret, like can you play with that, break it like locally, see what happens and so on?
Yeah, so for this specific contest, it was like, I mean, Ethereum is a set of rules that is well defined. So anything that doesn't comply with these rules is a bug and may be exploitable. So that's how I found some bugs in there. But most of the time, yeah, I need to really understand all the flow of the code base. So where are the user inputs coming from? Where are they going? For more consensus things, when there are multiple validators, what happens if one validator is malicious but not the others? And yeah, it's just following the flow. That's the thing that I'm doing. Sort of follow the money approach. I know that some security researchers that are really good are just going through all the files and having a mind map of it, but I don't. I need drawings to really follow the flow. Yeah.
Thank you.
Raul?
Hey, thanks for the talk. So I'm wondering, so the contest was done after the testnet incidents, right?
Actually, the Sepolia incident happened during the contest.
It happened during the contest. So
Yeah.
my question is, for the bugs that you found, why were they not catched during the testnet launch?
Because so for the Prism one, which is the one I know the most, is that you need to do 2 deposits with a validator that does not exist yet in the same block, which doesn't occur in the wild. It occurs only if you are malicious. or really bad luck. But for the the lighthouse one, it should have been spotted, I think, before anything else. But yeah, maybe sometimes it's too complex with the hysteresis, for example, thing. It makes it so complex that you can't cover every edge cases. Yeah.
Yeah, makes sense. Thank you.
Do we have more questions?
Yeah, thanks. Looks impressive. I just wonder, after you have found all these bugs, did the developers did they introduce more tests to discover these bugs in the future, or they have to hire you again?
Yeah. So, I mean, you can write a test, but if you... Yeah, there are so much edge cases. We write a test to prove it as security researcher. But yeah, thinking about it when you are a developer yourself, I think you have to have a security experience at some point and thinking, yeah, be paranoid.
Yeah, but they have Ethereum tests, right? They have a test suite.
Yeah, they have a lot of tests which are really high quality, but yeah, it's really difficult. And especially when you put it, the logic may be good, but in the context of having multiple blocks, which makes it a little bit different, then you would have to just simulate the chain and every edge case, which makes it really, really hard. Yeah.
Thanks.
Probably more like ethical question. Like, is it really secure? Because like, if everybody chases the money, right? If everybody knows this client is most popular, I will get probably rewards there, and nobody will look into other clients like that much. Yeah. So is it really fair to share this, like grade those vulnerabilities on current ratio of clients, right? Because it can change in future. That lighthouse Prism you mentioned, yeah, will be not the leading one, but others probably. And there is a bug some there, yeah, and something can happen. But nobody looked into that because it was like 5%, and everybody told, I will not look into that.
Okay. Yeah.
It's more like philosophical question.
Yeah. Yeah, security on the philosophy, like, I think that white hats may become black hats, but the opposite is not true. So yeah. Yeah. Like, what is really the question there? It's not. Yeah. Sorry.
Sorry to be intricate, probably. So the incentive for security researchers are like impact.
Yeah.
Yeah. You mentioned that Prism has the greatest impact because of the share, like how much you can split.
Yeah.
Right?
This is a thing with the bug bounty on Ethereum. It is based on the impact, indeed.
Yeah, but generally, probably more security researchers will focus on those like high incentived things, but will probably not look that much at like low incentived part. Yeah.
Yeah.
This was my question.
Yeah.
Like,
Okay.
how secure is it really? Because for me, it looks like it's pretty simple bugs. I always thought it's like cosmic things, but it looks like pretty simple. And I also was wondering about tests. Yeah. So it's like unit testing, not like end-to-end, probably.
Yeah.
And therefore, I have my doubts, right? Is it really secure? Because nobody will look at other clients which have a small share, and small usage, and there are no incentive to look for errors there.
Yeah.
Thank you.
Yeah, but I think that most of the time if a bug happens in Teku, for example, which has only maybe 10% of the shares, it doesn't have the same impact. So at the end, you will put money to protect what is the most important thing, and everything that is next to it is less critical. And yeah, It's just put the money where the risk is. Yeah. But yeah, for sure there could be bugs everywhere in code bases that are not that much used.
Does that answer your question?
Yeah.
We have time for one more question from the audience, and I gotta say, you guys have been amazing, amazing, especially this session. Like, I don't think we had this big Q&A and this much curiosity, like in the history. I think so. Like, I love to see this. Do we have any more questions?
Okay,
of course
go.
we do.
One more.
Hell yeah, that's the spirit.
That's maybe a spicy one, but can you comment on your sentiment of should there be a follow-up audit contest on this update, or how safe do you feel personally after doing this contest, and maybe what can we do in the future to what can we do in the future maybe to let's stick with the first question, yeah.
Okay.
So what's your sentiment there? Is it safe?
Yeah, I mean, most of my money is on it, so I trust it. And I think that even if there is a security issue that could break something, it has happened in the past. Social consensus will be the norm at the end, no matter what. The code may say, we sometimes say code is low, which is not true, because what we want is consensus between all the community. And if the code has something that is exploitable, we may roll back, even if it's only if it's a big issue. But yeah, do I feel confident? Pretty much, yeah. What we could do is, I know that the Ethereum bug bounty is up to 250K, which is pretty good, but not sufficient compared to how much of assets it protects, it handles. So that's something it should, 10x minimum.